In lesson 1, we looked at starting to divide fractions by whole numbers. Today we're going to do the opposite. We're going to take a whole number and divide it by a fraction. So we're going to start with an opening exercise just like we did yesterday. And notice it says to draw a model of 10 divided by 2. Now these are whole numbers, so we're going to go back to when we very first started learning about division many years ago. So there are two ways we can actually draw a model of this, and that's going to go along with the two ways that we can reword this question. So you may remember when you first started learning about division that you started with counters. So if you were going to do 10 divided by 2, one way you could do that is to take the 10 counters and reword this question to be how many groups of 2 are in 10. So I'm actually going to write that question down here as we're working. So how many groups of 2 are in 10? Okay, so I have my 10, and I'm going to circle groups of 2. So I've got 1, 2, 3, 4, 5 groups of 2 in 10. So 10 divided by 2 would be 5. So the other way that we can look at this problem is 10 is 2 groups of what number? So 10 is 2 groups of what number? So the way that I may model this is to draw 2 groups and then to start doling out 10 into the groups equally. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I could see that 10 is 2 groups of 5 in each group. Okay, so we are going to use these two questions and these two interpretations of a division problem to help us divide fractions. Okay, so example 1 says Olivia has 5 oversized chocolate bars. She wants to break them into thirds to share with everyone at her table in the cafeteria. How many people will she be able to share her chocolate bar with? So we know she's starting with 5 chocolate bars, and she wants to break them into thirds. Okay, so what that means is we're starting with 5, and we're splitting it up equally, or breaking it up into thirds. Now when we see this thirds, that's talking about 1/3 size pieces. Okay, so fourths would be 1/4, fifths, 1/5, and so on. So just like we interpreted 10 divided by 2 into 2 questions, we're going to do the same here, and then we're going to see which way is going to work universally for any type of problem like this. They both do work. One's just a lot more work than the other one. So the first way we reworded it was how many groups of this are in this. So in this case, we would be writing how many, and I'm just going to take out the word groups, so how many 1/3 are in 5. You can say how many groups of 1/3 as well, but I just say how many 1/3 are in 5. The other way that we worded this in this situation would be 5 is 1/3, and instead of saying groups here, I'm going to say of what number? Okay, so we've got how many 1/3 are in 5, and 5 is 1/3 of what number? It's just replacing the whole numbers we used in our opening exercise with fractions. So with the first model, if I'm looking to find how many 1/3 are in 5, just like the previous model, I started by drawing the 10. I'm going to start by drawing 5 whole. And I'm just going to draw rectangles. And it doesn't matter how you draw them, just as long as you have 5 rectangles. Now, in order to figure out how many groups of 1/3 are in these 5 whole, I'm going to split the 5 whole into thirds. So 3 equal sections in each one. and I'm going to count how many 1/3 are in 5. So each section is 1/3. This is 1/3, this is 1/3, this is 1/3. So I'm going to circle each one of these sections in each of the 5 hole. And when I'm done, I'm going to count how many circles I made and see that I get 15. Okay, so that's one way you can interpret a whole number divided by a fraction. The other way is to say 5 is 1/3 of what number? In this case, what I'm going to do is I am going to actually start with the 1/3. Okay, so I'm going to shade in 1/3. And I'm also going to draw and say that this is 1 out of the 3. Now the important piece here is this. 5 is 1/3. Anytime you see a number is a fraction, that means they represent the same amount. So 5 is 1/3 means that this 1/3 is also equal to 5. If this one section is 5, that means that 5 would go inside, or I can say 5 is split up over one section, or 5 divided by 1 is 5 in each section. That means that would be 5, and that would be 5. In these problems, you're looking to find the total. 5 is 1/3 of what number? So what I would do at this point is I would figure out what the whole would be, so what this whole rectangle would be equal to. So since 5 is in each section, and there are 3 separate sections, I would do 5 times 3 and get 15. Notice both gave us the same answer with 2 separate models. Okay, we're going to look at another example. And this example is really going to help us distinguish between which model is going to be easier to use for any type of problem where we have a whole number divided by a fraction. So in example 2, it says George bought 12 pizzas for a birthday party. If each person will eat 3/8 of a pizza, how many people can George feed with 12 pizzas? So we're starting with the 12 pizzas. We're splitting it up into 3/8 parts. Each person will eat 3/8. Okay, so the 2 different models. Once again, the first question was how many 3/8 are in 12. And the second question would be 12 is 3/8 of what number? Okay, so just 2 different interpretations of the same problem. So with model 1, in order to do this, we started by taking this number and drawing it. So I would draw 12 whole. Okay, and then if I'm looking for groups of 3/8, that means I have to split each of the 12 into eighths, which means 7 lines in each. I don't know about you, but I'm already a little tired of drawing all these lines. So this is actually the one that's not the best to use for all problems, because when our numbers start to get bigger, we have a larger whole number, we have a larger denominator, it gets a little tedious. To finish off, I'm not going to finish drawing all of this, but to finish this off, just so you can see how tedious it actually is, I would then have to go in and circle groups of 3, since it's how many 3/8 are in it. So I'd circle 3 here, I'd circle 3 here. Now there's only 2 left over, so I'd have to circle 2 from here plus 1 from this one, 3 here, 3 here. Oh, there's only 1 left here, so 1 here, but 2 here. So it just gets to be quite a lot. There's a lot of error that can be made here. But if we look at the second model, 12 is 3/8 of what number? This is where we would start by drawing our eighths, shading in the 3 I'm going to label that as the 3/8. And again, since it says 12 is 3/8, that means 12 and 3/8 show the same amount. So that means this shaded section is also equal to 12. Now the difference between this one and the previous example is the whole number was just one of the sections. Now it's split up over 3 sections. So we would take the 12 and divide it by the 3 sections, which gives us 4. Hopefully this is starting to remind you a little bit about the ratio tape diagrams we've already done. So now once we've split the 12 up over the 3 sections, we learn that 4 would be in each of those 3 sections. And then that means that 4 continues throughout the entire picture. So if I'm trying to determine what the whole is from this problem, I would take the 4 in each section, multiply it by the 8 sections, and get 32 as my answer. Now, think about that. Over here, if we had gone through, we would have made 32 circles in this whole picture, which is quite a lot. So this is going to be much easier to do for these types of problems.